All right, so we're going to have to do the 4 steps here. Our first step is going to be to draw the area that we're given. So R, the region, is a square with these vertices. So I'm trying to make a little picture. I got 0, 0. I got 2, 3. I have 5, 1. And let's see, 3, negative 2. So if you do it pretty nicely, you can kind of tell that it's a square. Mine's not that awesome. But let's see how it goes. So in this problem, I did step 1, I drew it. In step 2, I have to solve for u and v. I'm given that x equals 2u plus 3v. I'm also given that y equals 3u minus 2v. All right, so it's just debatable how you want to go about this, but I'm just going to go ahead and I'm going to solve this guy for u. So if I solve this for u, I will get 2u equals x minus 3v. And so basically I will get u equals x minus 3v over 2. And then I'm going to take that and I'm going to plug it into the other problem. So u is x minus 3v over 2. So y equals 3. U is x minus 3v over 2. Because remember, I'm trying to get u or v in terms of x and y, and then minus 2v. So you see what I've done right there is I have v's, and then x's and y's are going to go on the other side. So I'm going to multiply everything here by 2 so that that fraction goes away. So I get 2y equals 3, x minus 3v, minus, that'll be 4v. All right, so I got 2y equals 3x minus, that's a 9v, minus 4v. So I have 2y equals 3x minus 13v. So let's see, I have 13v equals 3x minus 2y. So I end up getting that v is 3x minus 2y over 13. Okay, all right, so there's my equation for v. So now I have to find an equation for u. So I think, what will I do? So I'm just going to go ahead and maybe use this guy right here. X equals 2u plus 3 times v. Well, I just found out that v was 3x minus 2y over 13. So this is a step that's the worst part, but we'll get through it. So x equals 2u. Actually, let me go ahead and multiply everything by 13 to get rid of the fraction. So 13x equals 26u plus 3 times 3x minus 2y. So now you see I have u with x's and y's. So I have 13x equals 26u plus 9x minus 6y. All right, so let's see. I got 6y plus 4x equals 26u. So u would be 6y plus 4x over 26. So u, divide everything by 2, 3y plus 2x over 13. All right. So those will be useful later. So step 3. Step 3, I have to get some equations, or tell what my new world is going to look like. So in this one, I have points. So what I'm going to do is I have my x, y points, and I have a direct relationship between x and y and u and v. I'm going to go to my u and v point. All right, so I'll make a little table out of this. So my old point in x, y world, my first one was 0, 0. So I'm going to be plugging these numbers into these two equations for x and y and come out with u and v. So if I put zeros for x and y in both these equations, I get 0, 0 again. So my next one I'm going to try is 3, negative 2. So I've put 3 and negative 2 into my equation for u. I get 0. If I put 3 and negative 2 into my equation for v, I get I get 1. All right, so then I'm going to try, let's see, 5, 1. So again, I'm plugging 5 and 1 in for x and y in these problems right here. So you plug 5 and 1, and for u and v, for u, you get 1, and you also get the same thing for v. And then finally, if you do that for the last point, 2, 3, plug 2 and 3 in for x and y in your equations, you will get 1, 0. All right, so you end up with this new world of u's and v's, and you end up with a unit square. All right, now that you and your loud friends left, my next step, step number 4, is to find the Jacobian. So for my Jacobian, I'm going to do the derivative of x and y with respect to u and v. So go back up here to my equations that I was given. All right, the derivative of x with respect to u is 2, and the derivative with respect to v is 3. So I'll be putting a 2 and a 3. And then the derivative of y with respect to u is 3, and with respect to v is negative 2. So 3 and negative 2. So I multiply, I get negative 4 minus 9, so it's negative 13. But remember, I put the absolute value in. So step 5 is to actually do my integral. I'm doing my double integral. I have this area that I'm trying to cover, so 0 to 1 in each case. I have to put in my 13, so I'll just put that outside. All right. All right, and now we have to go back and see what the original problem had in the integral. And I had x plus y. So x plus y, I'm going to go ahead and add these together. So that would be 5u plus v. And du dv. Okay, so then just do your integral. So you got your 13 hanging out here. Integral with respect to u would be 5u squared over 2 plus uv. I got to plug in 0 to 1. I still have dv to do. So plug in 1, I get 5 halves plus v. Plug in 0, I get 0. So this is what I'm left with. I do the integral. I still have my 13 here, 0 to 1 of dv. So I get 5 halves v plus v squared over 2 from 0 to 1. Remember, I still have my 13 out here. All right, so I end up getting 5 halves plus 1 half times 13. So you get 6 halves, which is 2, and 2 times 13 is 26. All right, so I know I said I would just do a short video, but I just want to show you on the next problem just the setup, and so that way it can maybe help you on number 11. All right, so this little space that we're doing here is the space that gets contained is this little space right in here. That is what's contained by this integral, and it's bounded by all these equations, 1, 2, 3, 4 equations. All right, so step 1 is kind of done for us right there. Step 2. I just want to show you that this can be a little bit easier than it looks on some of the equations, and I'm just going to stop after a certain part right here. But so step 2 is where I'm finding all these equations. I have u equals xy and v equals xy squared. So I have to find this in terms of, I have to solve for x and y. So you can easily see I was given this right here. So my bounding equation is xy equals 1. So xy equals 1 turns into u equals 1. And then the other equation is xy equals 2 right here. So that turns into u equals 2. Well, the other transformation equation I'm given is here. Well, that's v equals xy squared. So look right there. I got xy squared equals 1. That turns into v equals 1. And I got xy squared equals 2 right here. Well, that turns into v equals 2. So it's quite easy to go ahead and tell the area that you're doing in step 3 is this area from, I guess, you know what, that was all step 3, and I need to go back and do step 2. But anyway, you're able to see that it's between 1 and 2, and 1 and 2. And so you basically have this square. So when you do your double integral, you'll be doing 1 to 2 for both u and v. All right, so actually, let me go back. That was kind of more like step 3. Let me go back and do step 2. Step 2 was finding your new equations. So u is equal to xy, v is equal to xy squared, and let's see. So if I want to find an equation for, I could do y equals x over u, and go ahead and put that in there. So I get v equals x, and y is x over u, so it'd be x squared over u squared. All right, so let's see what that does for me. Oh, I had that backwards. Y equals u over x. Sorry about that. So that changes this to u squared over x squared. So that means one of my x's goes away, so v equals u squared over x. So that means that x equals u squared over v. And there's one equation. All right, now my y, I could, how about I bring these two things together? X is u squared over v, and then that's equal to, oops, hang on a second. So v equals x, which is u squared over v times y squared. All right, so if I flip that over, I got v squared over u squared equals y squared. So I'm just going to get that y is v over u. Okay, all right, so that's the worst part. And then the rest of it we'll finish in class. All right, I'll see you in class. Bye-bye.